don't sketch this. I'm just showing you. It would look like this. So in other words, which way was it before? This way, right? It was like this. Right? You keep going forever. And what happened? We switched it. But what's the problem? Why don't we keep it going forever? What? Well, no, why can't it? That's a good, I mean, you're right. It can't go past 90. Why can it not go past 90?
Because we can't have it greater than 1 less than -1.
No, but this isn't, this is going back between -1 and 1. Something else? Yeah, that's right. It wouldn't be a function. It wouldn't pass the vertical line test anymore. So we have to get rid of these curves, the rest of this. So what happens? This thing is stuck. It has to be between -90 and 90, and the calculator has been programmed that way. It knows, hey, don't give an answer that's 150 degrees, because that would be over here, and then violate the vertical line test.
If it wasn't a function, could you do that?
What do you mean if it wasn't a function?
Like if you made it not a function, you continued it, could you do that? Like if
That's right, that's right. Like we can graph this way,
but
and just say, hey, I don't want this to be a function.
Do we though?
No, we don't.
But why? Sorry.
Because we want to limit our results here, right? Because you know, when things aren't functions, that means there's multiple answers.
Right.
So we program these calculators, and I say we because you know any mathematician would tell you, when we solve an equation, we want unique solutions. We don't want just crazy solutions coming from anywhere. Okay, and that's part of it. Okay, so functions, remember, for every output, for every input, only one output. Like I can't have, because if I did, because there could be a 0, 360, 0, 720, 0, but I only want one output. Okay, so, all right, so you guys got to keep this information somewhere. This is the parent information for inverse sine. Okay, so now, what about cosine? What about inverse cosine? So on your calculator, do this. Do inverse cosine of -1/2. Do inverse cosine of 0.2. Let's see what kind of answers we get now. Take notes. You guys gotta get off your phones. What kind of answers do we get?
120 for the first one.
120 for the first one.
And then 78.5.
Okay, okay. All right. Would have messed me up, bro. All right. You had that pause. 78.5. Okay. So looks like this one went over 90. What do you think this one doesn't do? Yeah, it goes 0 to 180. So this one is in which quadrants? 0, 180 is over here. First and second. And again, no third. So how does this look? How does this look when we graph it? All right, so let's graph this one. So I have f of x equals inverse cosine of x. A nice table for this guy would be start at what? What do we put inside of this thing? We put numbers, right? We're going to go 1 to -1. So this one went -1 to 1. This one goes 1 to -1. Then we're going to put 0, then we'll put a half, and then we'll put -1. Yeah. Okay. All right, and then my answers are 0 degrees, 180 degrees. So what's in the middle? 90. And then this? 45? No, 45 gives us root 2 over 2, remember?
30.
30?
Mm-hmm.
No. 60. I was 40.
Yeah.
I was setting you up. I made you think it was going to be 30.
Almost.
Yeah, that's why I pointed over.
Yeah.
You fell for that, Brian?
Oops.
All
Yeah,
right,
I'm not
let's
perfect,
see,
okay?
Let's see. Look at this
don't judge.
animal. -1 to 1, and then here's 90 degrees, and this is 180. So what happened? Where are we? Where do I start? 1, 0. Right here. I like that sound. You don't like it? You don't like it? You appreciate it? And then no, half. And then how much up? 120. How about 60?
I don't know. I'm doing that way, that way.
Oh yeah. Oh, you're doing that way, that way? Yeah, I'll do this way, that way.
Okay, cool. Meet up in the middle.
You're right, actually. So there it is. So what is this one? Is it still an S? Yeah, but it now looks like it's backwards, right? It goes like this. Okay. All right. I. And again, this one's restricted. Why is this one above? And this one was kind of in the middle. Why is that one completely above? Because it goes from what to what? 0 to 180. It only stays in the pause, right? Quadrants 1 and 2. And this one went right -90 to 90. So it gets moved down. All right, now I want you guys to see that you can graph this. So on your calculator, I want to show you that it even knows to stop. So go y1 equals inverse cosine x. And then for our window, we have an x min, x max, x scale, y min, we need a y max, and y scale it. What are good numbers? And look at my x's are these. 2. Good. -2 to 2. Right? And then we'll put a 1 there. And then what? Hey, come on.
0.
Then what?
-360.
No, let's just do -30. These are the angles. Up to what?
180.
Good, 210.
Yeah.
Because I'm going to go 30 above, 30 below. Just give it a cushion. Right?
Bless you.
And then make sure you're in degree mode, because we're doing this in degrees. And then hit graph. Graph.
Wait, what's the y scale?
0. And look at this. Everyone should have that little S. Right? Nice job. Do you see it? And you see how it stops? It just knows to stop. Because it's not going to continue this, because it goes, oh, I'd be violating the rule for a function. Don't do it. Don't do it. Okay? All right, everyone hit second, trace. Second, trace. Trace is a button, starts with a T. Hit 1. And then put an X value in there. How about we put in, oh, let's get crazy here. Square root of 3 divided by 2. Square root of 3, close it off, divided by 2. Hit enter. And what do you see? What's y equal?
Nothing.
Nothing. I get 30 degrees.
30.
Yeah, 30.
Divided by
I hit second, trace 1.
Oh,
Second, trace 1, and then you'll get that x equals on the bottom of the screen, right? And it puts in square root. I said 3. Close it off, divided by 2, and hit enter. Right, that should be at the bottom of the screen, right? And it shows you where you are on the graph. Right, you're at 0.866. It jumps up here, and it jumps right there on the spot.
I didn't close it off.
Okay, yeah, and that's what happens. You gotta close it off. Right? Didn't it jump up there? And again, it's only going to, because we have to stay between -1 and 1, it's only going to give you answers in here, between 0 and 180. So your calculator knows. These things are pre-programmed. All right, and then, so inverse tan, I'm just going to give it to you. So let's do inverse tan. What do you think this is going to look like? So inverse tangent, and we're going to do this. x, f of x. Oh, let's see. My outputs are what? Angles, right? Let's go negative 90 degrees, 90 degrees, 0 degrees, 45 degrees, negative 45 degrees. And what do you think I get on top? What's the tangent of 45 degrees?
1.
What's the tangent of 0?
0.
What's the tangent of negative 45 degrees? So if you take the tangent of these angles, you get the answer on top. Does that make sense? Because it's backwards. What's the tangent of 90? Asymptote. Tangent of negative 90? Asymptote. So what happened? What do you guys think? Is that how we want this?
Wait, what was the space you just left there?
Of course she knows that.
What?
For negative 90 and 90, like what are those in dashes?
I don't know.
Did you?
Oh, hey, Bryn's here. You guys smile for the camera.
Yay.
Yay.
No. Just taking a picture.
Maybe. All right, so what happened here? What kind of answers do we get? Negative 90 to 90, right? So, negative 90 to 90. And what happens at negative 90 and 90? We have asymptotes. We have asymptotes. And then 0, 0. Right. Go over 1, you go up 45. Back 1, down 45. And you end up with this thing doing this. Okay, so it's a sideways S curve. Yeah.
Why is the first line it was like negative 1 to 1, and then there's asymptotes here, but the restriction was 90 and negative 90.
Restriction for what?
Well, like you see how there's like asymptotes, so you can't go above, and that
Yeah.
happened in sine. So like why?
See, remember, tangent is sine over cosine, right? And if I put 90 degrees in here, if I did the sine of 90 degrees over the cosine of 90 degrees, what's the sine of 90? Anyone remember the sine of 90 degrees? 1. What's the cosine of 90? 0. Can you divide by 0? No, right? So that's why at 90 we're going to get an asymptote no matter what. You just can't help it because it's causing a denominator to be 0.
Okay.
Okay. Now you could ask, why do these get cut off between negative 1 and 1? Well, that's because we get in a tangent we could put any number we want. I could put a 5. I could. In other words, can the tangent of some angle equal 5? Yeah. And the answer is yes. What is tangent? What over what? Think of SOHCAHTOA. Opposite over adjacent. I can have a right triangle with the opposite being 5 and the adjacent being 1. Right legs don't matter. But with cosine and sine, because like you know how sine of theta is opposite over hypotenuse, I can't put any numbers in there. How does hypotenuse have to compare to opposite? Yeah. It has to be bigger, right? And in a weird way, it can be equal to. That's when we get 1. But it can't be smaller. And that's why here we get these restrictions. Here we can put anything we want in there. That's why it goes forever. It's kind of a weird graph in terms of, to understand why it goes forever. Okay? But what this tells me is that I only get negative 90 to 90. So these angles tell you what kind of answers you have to have. Those are your outputs. Okay? All right. Homework tonight, 12-1, what was it?
12-1-3B.
12-1-3A, 12-1-3B. So you had A yesterday. So only do the book part. 12-1-3A is 12:37 to
12:43
and then 12:44
to 12:50.
Okay? So maybe you guys didn't do yesterday's because you were goofing around, or Wednesdays.
I finished it.
You did?
Yeah.
Okay. We can't all be like Brian.
I'm a good example.
Maddie thought it was due, so she, remember? Oh, your packet. Okay, if you guys have your packet, you haven't taken that in, I'll still take it. Remember, I don't have any more of these, so if you just have your homeworks, just put them together. Okay? Here's Jesse.
Can we do that for the rest
Why
of
are
the
there some missing?
No, I just...
I mean, we have like a month left,
it's easy.
right? Like, yeah. And if I recall correctly, the last day of school was on, it's going to be on June 7th. Yep, that's it. Yep. Thank you.
Okay. Maddie.
Oh, no, that's yours.
Give me a sec. My phone is hot. Oh boy.
You suck. No.
Good job.
A lot? Do I tell you I hit you? Okay. No, I did it today. I don't pick on you. I kind of spoil her. But it's because Lexi, she doesn't talk back. No, that's not that.
Okay, I think this will work. Hopefully. Let's try try to record this live stream at the corner, so hopefully this will work out. Just gonna do some homework and you guys can just like discuss ideas and stuff if you guys ever show up. And come on, there's like 54 of you. Or like technically 51. Hey, come on guys. Help a man out here. Like, I'm kinda like brainstorming ideas, but I can't do this alone. So come on, help me. Please, I'm open to suggestions. Go ahead. I'll just do my homework and you can like jot down your ideas from here, so go ahead and write them down. And this is my 4th period math class, IM3, integrated math 3 class. It's a pretty fun class because, you know, my teacher's a cool guy, so yeah, that's cool. Yeah, the phone's heating up a lot. It's not good. So yeah, go ahead and oh yeah, the book. Alright, I'll be right back.
Yeah, this is practice.
Okay, I'm back. Just need to get this math book here. This is my IM3 book. Just gonna use that. When the math homework done, so I can live stream more Smash content later instead of doing this boring school stuff. But you know, taking the opportunity. Oh shoot, that's too far. Wait, that's just a bit too far. Oh. I think I made it. Cool. Hey, what's up, Charlie?
What's going on, Brian?
Not much about you, man.
Nothing much. Just my notes and now stop the period.
Yeah. Good note time.
I'm surprised you're not a solver.
Alright, let's see if 1244. Green lesson is confused about domains for inverse functions. Explain why instructions are needed. Okay. Hold up. I need to buy a phone stand for this, so that way I have to like press things among like certain objects instead. That would be pretty annoying.
You're making me say it. I don't want to say it.
Actually, you know what? Let me just put like. Yeah, this will be good. I might not show my face much, but you guys can see my mouth talk. Alright.
Oh yeah.
Yeah, I can't work without earbuds either.
Here we go, TA.
I don't even have freaking headphones. Come on now.
Okay, so if they're stable, everybody in that group gets a score. But you're gonna see some that might not. That look good.
Actually, that's not true.
Yeah. I ain't the only one. I'm the real G. Alright, so lamp. Dude, did I say you can go back?
Yes, we're trying to practice for next year.
Yeah, have a good one.
Wait.
Did you hear the singing last night?
You're sick.
No, because one of the trophies.
You're celebrating just yet. Where was it? Cat? Where's the cat? Whoa. Monticello? Why was she tardy? She said. Jack? Where's Jack? With Brooke? Is it? I'm sure it's going to be out of town.
Alright, one palm down. 4 more to go, I think. No. 1, 2, 3, 4. I got 6 more. Well, I got 6 more to go. Dang it.
TA was tardy.
Oof.
Yes, we have a TA. Yeah, but this is the best TA I've ever had.
Alright, Bear, I need to get tissue.
Okay. Yeah. So now go to period.
One day. Come on, man.
Mr. G, I accidentally threw the football on the roof.
It's up there?
Yeah, but it's okay. I can tell people to go get it.
No. I can get it later. Don't worry about it. You're not the first one. Bo Bank Port taking it up.
Mr. G, you want to see how she runs the rip?
Oh. It's up. But which one? The one that was getting flat a little? Okay. That's all right. I'll get it later. Hey, does this belong to anyone in here? Okay, I think it's from my 5th grade then. I can't remember who I saw one. That's all right. Bryn, did you hear that? Your football got stuck up on the roof. Yeah. I won't throw it at you anymore.
I feel bad.
No, it's fine. Alex. No, who's it with Brooks? Oh, that's the Oregon. Yeah, that's Brooks. I did, didn't I?
I say free.
Yeah, exactly.
One of my favorite things.
Yeah, I only have money.
Because I don't want to see you again. I don't want to see you again. Here, let's look for it. Sit down. Sit down. I'm gonna drop kick you. What the fuck? I hate when you guys cram them in there like idiots. Just cram them in there just for you. Let's just do, let's go with this one. Okay, divide both sides by 2.
You play Fortnite? How would I get there? Yeah, so go like this, right? Okay, go alpha, y equals and I get negative 66. So put beta equals negative 66.
No, because they don't let us.
Here's the key. First one.
No, because
You gotta put, then there's another answer. For inverse tan, plus theta 1 plus 1.
or like you guys go.
So what are we working with? So how do I get the other one with these two out of 180? It's 180 minus that, minus negative 60. So I hit on 180 minus negative 60. Okay. That's how it is. Why were you late? What about it? Hey. No. What do you have to make up for it?
Alright, give me a second. I just need to take care of something real quick.
Do it next week. It's 0 and you see your scores, right? Why are you satisfied with that? Are you a senior? No. Okay, don't act like it. No, seniors act like it. You guys just, I don't care, I just need to pass. I don't get pretended. See? So don't ever be like her. Well, don't ever be like her, period. As you walked away from it. Okay, Monday, you said.
I have a quick question.
Yeah, Brian, good. Finally, a good student.
I forgot how to represent how the solutions are. Okay.
Third one. Can you reach? No. Yeah. No. Yeah. Yeah, that's right.
I forgot how to represent the solutions for tangent. Like something like this, right?
That's right. That's it.
Oh, that's it? Oh, yeah, that's one. Oh, yeah. Okay.
You get one.
Yeah, you're right. Okay. Okay. Alright, got that down.
I walked over here with Emma
Oh no, I didn't run out of space. There's still more here. Okay. Hold on. Let me get all of this spaced out here. Yes. Okay. Okay, so I'm gonna write down 1240 5D. Maybe just one more part here. Yep. Cosine. This 4 to the side. 4 here. 4 cosine x. Divide both sides by 4. the cosine of this. Get the arc cosine of that. Let's sharpen this pencil. I mean, I could have just tried to sharpen it aggressively as I could, but whatever. Alright, goes new.
God, I missed one. No, that's not acceptable. I know, I'm so stupid. I know that. And the rest of you guys are like, I haven't decided.
You guys probably might be but you would never.
I can get a tissue real quick. Be right back.
I gotta add up low numbers here. Let's see. Where are you? Frederickson's and Son. No, because I thought you actually had a high school.
Okay. Hopefully no one passed by and like gets suspicious of this live streaming activity going on at the moment, but so far I don't think I got caught yet. Still in the clear, sort of at the moment.
But that's before a curve. Yeah.
Okay, got it.
Okay, so let's see. According to Johnson.
Describe each transformation below in terms of the paragraph of this. Okay, so there's one way I can do this, so I can like graph the.
Okay, so let's see. According to him, it was 50.
So this of this go up by 1. What in the heck just happened to this graph? It looks more like flatlined. Hold on, let me go back down here and it's literally going flatline. What the heck? It's because it's in degree mode? What happened to it? Let me try to mode in this. Hold up. Oh, interesting. So, let me zoom out real quick. Oh, what the heck? Okay, so I tried to graph this in radian mode, and like this is what happened. Oh shoot! I dropped my calculator. Whatever. But this is what happened. It's like continuous functions of. I forgot what it was, but something like that happened. But I guess it's what happens when you change the mode. If it goes like degree mode, it's gonna go like flatline, so that's unfortunate.
Please. I'm begging you, it's so bad.
It's Mother's Day. What? Can we leave? No. Bell hasn't run. Guys, wait for the bell. If you leave early, that means you're leaving points here.
It's okay, one person left.
Oh, wait. Even in the homework?
We have one more word.
It's not smooth.
See, you're doing.
Oh, really?
It's like all the Wednesday live and stuff.
You been there? Nice. Yeah, aren't there like different campuses? Yeah, right. They all have
Alright, you want to go on the stream here, guys. So, some ideas. Well, guess we'll have to get to do this another day. So, see you guys later. Just have to get ready to find something off. Peace.